Hello everyone. In this video, let us discuss the concept of supermesh and thereby understand how to apply mesh analysis if we have a current source in common or between two meshes. So now let us first understand the definition of supermesh. So a supermesh is formed when two adjacent meshes share a common current source. So as you could see here, this current source is common to both mesh 2 and mesh 3. So we have here mesh 2 and mesh 3. So it could be seen that this current source is common to both mesh 2 and mesh 3. And hence we say that this is a super mesh. Okay, so a super mesh is formed with two adjacent meshes that share a common current source, and none of these meshes contain a current source in the outer loop. In the previous video, we have seen how to solve a problem where you have a current source in the outer loop. Right? Now, even for the formation of supermesh, you have to understand that you should not have any current source at the outer loop. So this is the outer loop. Okay. So here you are not supposed to have any other current source. Only then you could form a supermesh. So here, whenever you form a supermesh, you are going to combine two adjacent meshes and you're going to see that as one mesh. So now let me take you to a problem and explain how we are going to apply mesh analysis to a circuit where you have a common current source to two adjacent meshes. So find the current through 10 ohm resistor for the given circuit. So here we have 10 ohm resistor and we are going to find the value of current that is flowing in this 10 ohm resistor. So first, let us go to the first step. The first step is assume mesh current by identifying the meshes. So the mesh currents are already given. So let us go directly to the second step. So based on the direction of current, we are going to assign polarity. So remember the convention, current enters this point, so plus, and then current is going to leave this point. So here a minus, plus and minus. So current enters, leaves, and we will not put any plus minus for the source. Okay, again going to the second mesh. So here this is the direction of rotation. So let me start from here. Current enters plus, and then here it leaves minus. You come to a current source, so you're not supposed to put plus or minus, and then current enters this point, so plus, current is going to leave this point, so here a minus. Okay, so now over to the next mesh. Okay, so here let me start from this point. Current enters, so here plus, and then current leaves, so here minus, and then this is a current source where you're not supposed to put plus or minus. Okay, so now let me go to the next step, that is apply KVL to the mesh, right? So let me start from mesh 1. So apply KVL to mesh 1. So remember to walk along mesh 1. Okay, so this is mesh 1. So I'm going to take a walk along mesh 1. So take some random point and you're going to start from there. Start your walk from there. So when I walk, I travel from minus to plus. So after the equal to sign, I write 2. And then from plus to minus, I see a voltage of 1 into I1. So it is 1 into I1 plus, so I have crossed this element. I travel again from plus to minus, whereas here there are two currents, right? So plus 10 into I1 The other current is minus I2. Minus I2. Okay. So I have now completed my rotation and I have come to the starting point itself. So this, I have the first equation. Now to the second equation. So let me start applying KVL and let me explain why we go for a supermesh. So let me start from some random point. Say I start from this point. Okay. So let me start my rotation from this point. So I'm going to go here plus to minus. So I have a voltage drop. So it is 10 I2. Okay, so let me write 10 I2 minus I1 plus, again I travel from plus to minus. So it is 5 into I2. Only one current is going here, I2. And then when I come here, I have a current source, and till I solve the problem completely, I don't know the voltage across a current source. Okay, so across the current source, I will not know the voltage till I solve the problem completely. So even now, the voltage is unknown. But when you apply KVL, you are supposed to write the voltage, right? So we are not in a position to write the voltage equation because we have a current source. Similarly, you'll have the same difficulty here when you try to write the equation. So you'll write 15 I3 plus அதுக்கப்புறம் என்ன I will not know what to write, right? So in order to overcome that difficulty, this branch is the branch where I have a problem, right? So this is the branch where I don't know the voltage. So I just omit this branch, okay? And I form a super mesh by combining these two meshes. So I say I form a super mesh. A super mesh is formed by combining mesh 2 and mesh 3 that have a common current source. So let me repeat, a super mesh is formed by combining two adjacent meshes having a common current source. So what are those two adjacent meshes here? They are mesh 2 and mesh 3. Okay, so I have combined these two meshes and I have now formed a super mesh. Now let us apply KVL. Okay, so now let us apply KVL to the super mesh. So as you apply KVL, so let us start from one random point. So you travel from plus to minus. So you have here 10 into I2 minus I1. So 10 into I2 minus I1. And then here it is plus 5 I2. And then instead of coming here, this is our super mesh, right? So whichever I have highlighted in green. So after you come here, you are not going to take a turn here. You're going to go straight. And then you're going to write the voltage drop that you find here. So it is from plus to minus. You find a voltage drop 15 I3. And then you come back to the starting point. You have not seen any voltage from minus to plus. So put it as 0. So that is where you have the second equation. So first equation is a normal mesh. So you wrote the equation simply by applying KVL to mesh 1. Whereas if you come to the second and third mesh, you had a current source in common. So we form a super mesh by combining these two meshes together and we have applied KVL to the supermesh. Now we have only two equations, but the number of unknowns in our system is 3. So we have 3 unknowns. If you have 3 unknowns, in order to know or calculate these 3 unknowns, you have to solve 3 equations, right? So you know every circuit has a unique solution. So a unique solution is possible with 3 unknowns only if you solve 3 equations. But now you have only 2 equations. So now let us consider the branch which we omitted earlier. So that is where you have a current source, 4 ampere, right? It is seen here that I2 is flowing in this direction and I3 is flowing in this direction, right? So I could say that here I have a current. Okay, so I3 is flowing in this direction, I2 is flowing in the opposite direction. So here I could say I have a current of I3 minus I2. So this I3 minus I2 is equal to 4. Okay, so this is going to be my third equation. And solving these 3 equations, we have the solution. So the solution is I1 is equal to minus 2.35 ampere, I2 is equal to minus 2.78 ampere, and I3 is equal to 1.22 ampere. So it could be seen that the direction that we have considered for I1 and I2 are going to be opposite to the actual. Because of this minus sign, we understand that. Okay. And what does our problem ask us to find? Our problem is to find the value of current through 10 ohm resistor. So here we have the 10 ohm resistor. So let me draw the 10 ohm resistor separately. So I have the 10 ohm resistor, and it could be seen here that I1 is the current that is flowing in the downward direction, right? So I1 is equal to, so I write the value itself here, I1 is equal to minus 2.35 ampere if the current's direction is downward, as you see here. Okay, if the current direction is downward, it is minus 2.35. If you're going to take the current direction in the opposite way than what it is given, then you need not put this minus, right? So now I write, okay, I just change the direction. Okay, and I have one more current flowing in this resistor. So that current is, so here you have, okay, so I2 flowing in the upward direction. Okay, I2 is flowing in the upward direction, and it is given that I2 is equal to minus 2.78 ampere. That is, you have a minus sign. So you take the minus sign and you reverse the direction of the arrow mark. Okay, so here you could see that you have two currents flowing in the 10 ohm resistor. They are I2 and I1. So I write the current through 10 ohm resistor is equal to the greatest current I2 minus I1, because they are flowing in the opposite directions. So the value of current that is flowing in 10 ohm resistor is the difference of I2 and I1, which is 0.43 ampere. 0.43 ampere. So let me just conclude by drawing the 10 ohm resistor alone. So I2 is the greatest value of current, right? So the net current is going to be the direction of I2. So in this direction, you will have the net value of current, which is 0.43 ampere. So this is our final solution. Okay. So I believe you understand what a super mesh is and how to solve a circuit when you have a current source which is common to two meshes. Thank you.